The distance between any two consecutive points that vibrate in phase on a wave is the wavelength, right? So 1.1, our answer here is going to be B, right? Because the distance between any two consecutive points that vibrate in phase is wavelength, right? And then off to 1.2, a wave moves past a fixed point at a speed of x meters per second. If the speed of the wave stays the same and the frequency of the wave doubles, then the wavelength of the wave will, A we have half, double, remain the same, and increase fourfold, right? So here, let's conceptualize, right? We know that we have V being equals to frequency multiplied by wavelength. So it is said that the frequency has been doubled, right? But then the velocity or the speed stayed the same. So what happened to wavelength, right? So let's say our initial frequency was 2 hertz, right? And then our wavelength was 2 meters. So V would be 2 multiplied by 2, which is equals to 4 meters per second, right? But then now it is being said that the frequency has been doubled, but the velocity remains the same, right? So if the frequency is doubled, then we're going to have V being equals to, so instead of 2, we're going to have 4 hertz, right? And then multiply by, we need V to still be 4 meters per second, right? So the wavelength now has to be 1 meters so that the velocity remains being 4 meters per second. So you can see it with this illustration that if we double the frequency and you want the velocity to stay the same, you have to halve the wavelength, because here we had a wavelength of 2 meters to get a speed of 4 meters per second. But then now that we have doubled the frequency, we only need a wavelength of 1 meter, right? So that's how it works. This might be a bit challenging, but then if you put some thought into it, you will realize that it's not too complicated. And then now we have 1.3. 1.3 saying that the diagram below represents two sound waves, A and B. Which one of the following combinations that compares the frequency and loudness of A and B is correct? Let's look at option A. It is saying that the frequency of A is greater than that of B, right? So let's go on our sketch and see if that is true. So from here to here, we have one completed wavelength. And then from here to here, we have one completed wavelength. So if we assume that on the x-axis we have time, then that will tell us that the period of A and B is the same. And then if the period of A and B is the same, then the frequency should be the same. So now the only options we're looking at is option C and option D, because they're saying that the frequency of A and B, they are the same, right? And then let's look at the loudness, because that's the other criteria we have. Option C says that the loudness of sound wave A is greater than that of B, right? What is loudness related to? Loudness is related to the amplitude. We can see that the amplitude of B is greater than that of A. So our answer here for 1.3 is actually D, because the frequency of A is the same as the frequency of B. But then the loudness of A is less than the loudness of B because of the amplitude. Sound wave B has a higher amplitude. And now off to 1.4. So we have 1.4 here saying that doctors use certain equipment to check on the health of unborn babies. This equipment uses, we know fully well that this equipment uses ultrasound, right? So our answer for 1.4 is going to be option C.